Hello everyone, in this video we introduce Shan Liang Ren, a personalized fully quantitative nutrition agent. When planning nutritional diets for different populations, it is not only necessary to meet the nutritional intake goals set by dietary guidelines, but also to accommodate users' personalized needs, such as dietary preferences, restrictions, and allergen avoidance. However, these two aspects often conflict with each other. Therefore, the core challenge of personalized dietary planning lies in how to capture users' individual requirements and, under multiple personalized constraints, identify dietary plans that best meet nutritional intake goals. To address this problem, Shan Liang Ren first collects users' basic data such as BMI through questionnaires and automatically converts them into applicable targets based on dietary guidelines through multi-round interactions with users using dietary drafts and by employing a natural language-based human-in-the-loop approach. It progressively captures users' personalized requirements and transforms them into a structured set of constraints. Then, based on an exact subgraph matching retrieval-augmented generation RAG mechanism, it retrieves candidate dishes and ingredients that satisfy the constraints from ingredient and recipe databases using the world knowledge of pre-trained large language models (LLMs). It narrows down the feasible solution space. Within this feasible solution space, multiple complete candidate dietary plans are generated. Next, based on these candidate dietary plans, the system fine-tunes them using Pareto optimization algorithms with respect to multiple nutritional intake objectives. Ultimately, it generates dietary plans that satisfy the hard constraints and achieve optimal nutritional goals. Now, let's begin the demonstration. First is the user information and preferences setup. On this screen, users can enter basic details such as age, height, and weight, and set their dietary preferences, restrictions, allergens, and meal structure requirements. These inputs will be transformed into structured constraints for subsequent feasible space construction and nutritional goal optimization. After clicking Generate, the system begins the dietary planning process. First, using an exact subgraph matching-based RAG mechanism, the system retrieves candidate dishes and ingredients from the recipe database that satisfy the hard constraints, forming a feasible solution space. Then, within this feasible solution space, a large language model generates multiple complete daily dietary plans. Next, the system performs Pareto multi-objective optimization on these candidate plans to generate the one that best meet targets for energy, protein, fat ratio, and other nutritional goals. Here you can see the multiple candidate daily dietary plans generated by the system, along with the optimized recommended plan. Next is the display of nutritional metrics and optimization results. For each candidate dietary plan, the system performs deterministic calculations based on the ingredient nutrition element table to obtain the daily intake of nutrients and their target ranges. These target ranges are all personalized based on the user's own information, such as BMI. Each nutritional metric is then compared with the recommended ranges from dietary guidelines, and the interval deviation is calculated. By quantifying these interval deviations, the system can characterize the extent to which each nutrient's intake deviates from its recommended range, enabling a computable assessment of how well the generated dietary plan meets nutritional goals. This also ensures comparability and verifiability among the candidate plans. The explanation content is generated based on actual nutritional calculation results. The system specifies which nutritional metrics meet the targets and which show deviations. At the same time, the explanation module clarifies the basis for trade-offs made between personalized preferences and nutritional goals. By grounding the explanation in deterministic nutritional calculation, results, and constraint satisfaction. The system enhances both interpretability and trustworthiness, allowing users to clearly understand how the plan was derived. This also strengthens the verifiability and transparency of the optimized results. Unlike conventional conversational agents that primarily rely on dialogue, Shan Liang Ren allows users to provide feedback on dietary draft plans directly in natural language, enabling them to express personalized needs intuitively. The system automatically formulates an optimization problem based on this input and solves it, avoiding the issue of user interactions deviating from the core topic of dietary planning, a common challenge in dialogue-based scenarios. When users are not satisfied with the initially generated dietary plan, they can further refine or adjust constraints based on the existing plan using natural language, for example, by adding new dietary restrictions, strengthening specific nutritional intake goals, or modifying the meal structure. The system reparses this secondary user feedback into structured constraints and automatically reconstructs the optimization problem under the updated constraint set, generating new candidate dietary plans. This enables an iterative optimization process that continuously adapts to personalized user needs. Finally, the data support component. Shan Liang Ren relies on a recipe database, an ingredient database, and a fully quantified nutrition element table to support Shan Liang Ren in generating reliable dietary nutrition plans. We have constructed a recipe database containing 1,550,150 recipes and an ingredient database containing 64,127 ingredients, all of which have been fully quantified and calculated across 64 nutritional dimensions. Shan Liang Ren provides structured support through its recipe database, ingredient database, and fully quantified nutritional data, enabling dietary nutrition planning to perform deterministic calculations and multi-objective optimization under well-defined constraints, while ensuring verifiability and interpretability of the results. This concludes the complete workflow of Shan Liang Ren.